Hello.
Hello, guys. I'm delighted to welcome you to our Python event today. And before we begin, I would like to introduce myself, our company, and of course, our speaker, Andrii. My name is Oksana. I'm a recruiter at Beetroot, and I'm always available to discuss our open vacancies and projects with you. Today, I will be serving as a moderator of this event, and we are proud to represent our company, Beetroot, which is a Swedish IT business with around 500 specialists in it. Our head office is located in Stockholm, Sweden, and we have 7 co-working spaces in Ukraine, one in Bulgaria, in the heart of Sofia, and another in Poznan, in Poland. Beetroot is a sustainable partner for software development services. We specialize in building teams with a focus on mental health, wholeness, and long-term mindset. And we work with some of the best tech experts in the industry and create teams of engineers and designers for projects worldwide. Our key areas of expertise in health tech, ed tech, and green tech, domains that push humanity forward. Today, we are happy to have one of our talented tech developers, Andrii, present his pet project which uses asynchronous programming. Andrii is a part of our internal development team and has put together an excellent presentation for us. And during this event, I will be monitoring the chat and reading any questions you may have for our speaker. Please feel free to ask anything you like. So please welcome Andrii. Andrii, the microphone is yours, and let's get started.
Thank you. As I was presented, I'm Andrii Diemientiev. I am a Python developer with a 5-year experience, and I'm here for you to introduce asynchronous Python, to tell you about it, show you some tips and tricks, and just to have fun, I think. I prepared 2 actual projects. The first asynchronous meetup I presented for a short circle of people, small circle of people. I made a technical project that tracked the lights on and off in an apartment, and I used asynchronous to speed up the process of receiving data from the queue and uploading it to the database. But I think it's quite heavy to understand it right now, and I prepared another project. This one will just parse the Wikipedia and upload the data from it. The idea is to get the actors' films, like the Academy Awards nominated actors or the Academy Award actors that won the Oscar, and to get their films and to write it into the files. But before that, let's jump into asynchronous programming, and actually we will talk what it is, what's the basic elements, what's event loop, coroutines, tasks, what is blocking and non-blocking code, and I'll show you some tips and tricks how to deal with the asynchronous code. We will have 2 sessions of question. First one will be after the theoretical part. We will have the presentation. You will already see it. We will go through it, and after that we will go to the code. So the first part of the question you can ask after the presentation itself, and in the end, after the code block, you actually can also ask all the rest questions. So let's dive in. Asynchronous programming. To get the idea of asynchronous programming, we might imagine the master of chess playing with 20 other people. And you know the synchronous programming, I think. The synchronous programming, when you're doing all actions one by one, all in row, let's say. And if we're talking about this master of chess, he will play with each participant separately. Yeah, like he will play with first one, and after finishing the game, he will go to the second one, and so on and so forth. If we're talking about asynchronous programming, we will take the same master of chess, and he will play with the first, second, third, and all other one at the same time. But the idea is when he made a move with the first opponent, until the opponent thinks of his move, he can go to the another one, and so on and so forth. So he's not waiting for a response from the opponent. He just makes a move and goes to another. This is actually, in basics, how async.io also works, how asynchronous Python is working. You have code that has blocking and non-blocking operations. We're talking right now about non-blocking operations. I will explain in details what it is, but we have some kind of calls to, let's say, files, maybe sites, yeah, maybe databases. And at this particular moment, code waits for the response while it can make a call. And if there is no immediate response, the code can go to another part of the program and start working on it, start doing some useful things. And when the callbacks go, will be callback about that the results of the request is in it. So like you have it, so you can work with it. We're going back to this part of the program and continue working on it. We will also, so let's go to the details about the basic elements of the async.io. We have two keywords. It's async await. We also have such huge thing, which usually is under the hood. It's event loop, who manages all this work of functions, and we have coroutines and special types of the coroutines. I will talk about them. So if we're talking about event loop, it's the core, yeah. It's basically thing that manages and runs all the tasks, all the coroutines, all the functions in it. It knows when it must change the context to another coroutine task. You see the diagram here, yeah. We have a task queue where all the coroutines or functions, let's say function for now. I will explain what is coroutine on the next slide. We have functions, which, and this event loop monitors this task queue and sends tasks to execution until it sees that there is IO operation coming up, and it changes, it checks if IO operation actually works or not. Like if it's if we received result of it or not. If we're still working on it, it switches the execution to another function, and so on and so forth. We can use loops, event loops, with two types of APIs, I would say, two types of calls. The first one was introduced back in Python 3.4, and it's a low-level API. You can get from async library the event loop itself, and then say what you need to do with this loop. Yeah, you send in the function into it and waiting until it executes. In the Python 3.7, there was a high-level API introduced. And right now it's, you mainly don't need even in your regular application to work with low-level API. You might just need to use async dot run, and you're already working with this event loop, and it's doing all the job until under the hood. Yeah. I talked a lot about coroutines, and you might want to ask, what is this actually? Coroutine is a basic function, yeah, like each Python function, but it a little bit smart. It look like generators, and actually uses some of the tips and tricks of the generators under the hood. The idea is that coroutine can enter, exit, or resume its work in any point, or mostly in any point of the program. And it can interrupt itself and move the control to the event loop, and the event loop will move the control to another coroutine. This, you see here the example. Yeah, you see here the diagram itself. That event loop constantly uses workers and send the coroutines until the IO operation interrupts it, and the event loop gets the signal about it and moves to another coroutine, and so on and so forth. We can implement coroutine and define coroutine in pretty easy ways. Basically, it's async keyword before the function. When you're saying that async, when you're typing async before a function, you're already defining the coroutine. If you want to use a coroutine, you might use await keyword to get the result. So the await keyword, it's crucial thing in the asynchronous programming, asynchronous Python actually. It basically says everything. Yeah, it awaits for result from the coroutine. If you're typing it if you're typing just the name of the coroutine without await, you will receive a coroutine object, and you need to do something with it. It won't be executed until you type await and coroutine name. It won't be executed, and it won't be sent to the event loop. It's crucial to understand, and I think I will show you why. Besides of that, we have two types of execution of coroutines. Yeah, it's tasks and futures. The tasks itself, it's a wrapper around coroutine. It helps actually to send coroutine for execution. We might just say async.create task and the name of the coroutine, and event loop picks it up and tries to execute it. It has mechanism in there under the hood like a future. I will tell about future just in the next couple seconds. But get this idea. Yeah, task just wraps coroutine, and then it asks event loop if you can execute this coroutine, and waits until the coroutine sends signal back. As soon as coroutine sends the result, or basically callback, we can gather the data of this task. Yeah, we will have, I think, io.gather to function to get the result of the task. It's pretty useful to run a bunch of jobs, a bunch of different functions in the same time, mostly. Yeah, you send something to the event loop, it starts executing. Let's say you send 10 functions at the same time to event loop, it starts execution, and it sees that IO operation coming up, and it changes the execution to another coroutine, and so on and so forth. So it's the time when you have this IO operation, you can execute additional work. Yeah. I told about the future. Future, it's also an object. It's a low-level object, quite specific one. Tasks users need a lot because they inherited from the futures. I'm not an expert in the futures, and I don't think you will actually see it a lot, but you might understand. You need to understand this idea of the callbacks and the future itself to get the idea how tasks is working. So futures, basically, they saying that, okay, right now, I have the code I want to execute, and I send it to event loop. And then future waits until the value of the future is set, until basically something in the program saying that, okay, you can send back your results. And at this point, when you have some results set it up, you can get the execution of the future. You can basically grab the results of the execution and another part of the program. It uses callback mechanism. I will show you examples of the code, how it works. Yeah, but as I said already, you won't see it a lot. It's mostly for writing libraries or something good like that. I even haven't found good code examples in the internet about futures. You can check here on this slide how tasks and futures defined and how you can get the result of their execution. They're pretty similar. If you want to define a task, you just wrap your coroutine in the create task function of Async.io library, and it's already starting execution. Yeah, and you're grabbing the result after with Async.io gather. If you want to use futures for kind of the same functionality, you have a low level of API to say when you want to set your result and when you want to return the result. Yeah, we have main function, we have this part, the future object, and then we're stating the result in the set after function and getting it from the in the main. Yeah, so it's kind of weird thing. I took this example from the original Python documentation. You might find better explanation there. I want to also talk about blocking and not blocking code to show you why it's why we need to understand those and to operate with those. So blocking codes and blocking IO operations, basically it's everything that blocks your execution of program. When you're using synchronous libraries, when you're using some synchronous codes, like you see here, yeah, the example, yeah, the request library, actually it's a synchronous library and it doesn't support async constructions. And if you will use this request library in your synchronous code, you won't be able to context switch. Yeah, you won't be able to switch the execution of your operation from one coroutine to another. So be aware of this. Non-blocking code in this particular example, yeah, it's something. It's code where you can actually change your execution threads to another. You can change execution of coroutine from one to another. And here we have IO HTTP to substitute the requests, and basically session, yeah, to get the data. So this await response.text and session get, they actually non-blocking code, yeah. Before we go to the code itself, is there any questions?
Unfortunately, no. I hope that everything will be clear. But guys, if you have any questions, please ask us in the chat. We are waiting for it.
Cool. I will drink my tea because it's so short. Thanks. So let's get to business. Here we have this script. I will make it bigger for you guys. So, as I said, what the script is doing? We are getting the data from the Wikipedia page about actors that was nominated. We are going through all the Wikipedia pages with those actors, and we're trying to grab the data of films that basically there are films, yeah, but the films where they were an actors, and writing everything into the files. Though it's quite simple program, but here's also a couple things you should understand about, well, couple unusual tricks to speed up this program. Well, let's go one by one. Main function, we have a year. It's a date of birth of an actor, basically year of birth. Then we go into the function that gets the data from list of actors with Academy Award nominations. It's all the actors. I might probably open the page itself. Give me a second. So basically, we are going through this page, and here we have list of actors. We get in the data about an actor name. We get in the link to an actor, and we're also getting the data about the date of the birth. First thing, the page. Second thing, Beautiful Soup, it's a library which helps us parse HTML code and make it usable for us. Yeah, not the text, but we can actually get some HTML text from it and check the elements of it. So it's a parser. I'm parsing with it the page and getting the data from the table, which has classes sortable and wiki table. I won't show you that this is actually the this table. Yeah, I won't open the inspector. You will have to believe me. And yeah, as soon as we have this Academy Awards table, we go through it, get in the first cell, which is the name. We also get in the third cell. Yeah, here, first cell, third cell, which is date of birth, and we extracting all this data and putting it into the dictionary. After we get in all the data, we go into this particular area. It's get film history. I will perform some actions right now to a little bit slow down the code. For now, we don't need all of this stuff. Yeah, going back to the film history, we're going through the actors dictionary, getting the page of an actor, and then again, we are trying to find this table, which has this class like wiki table and sortable. In most pages, you can find it. In some of the pages, you cannot. All pages actually, they're different, and you might need to adjust your script to get all of the data. For now, it's I think finding something like 4 or 5 different film histories, like film histories of different actors. The rest of it just cannot find on the page. But yeah, we get a film table, going through it, getting the data about the year and about the name, and so on and so forth, and writing it into the table itself, not the table, in the file itself. Let's try to execute it. I think I might delete all of this. And we will execute, and then we'll check the time. So we see here that it found around 10, maybe 15 different actors. Some of them it cannot parse, and the other, well, the result is here, something like that. Okay, it's not that, something like that. Melissa McCartney, you have year and film. Well, works not good, but at least it shows we need. And we also see that this particular script took 15 seconds to be executed. I will put it here as a reminder. So right now, you probably want to speed it up a little bit. And I have an asynchronous code for speeding it up. Here we have same idea. This is our loop. We put in our coroutine, main coroutine into it, and we are putting there the actors' years of birth. Our main coroutine actually, it's quite simple and mostly the same. Yeah, we have same idea. Search actors and then get the film history. If we're going here, as you see, I haven't actually made this function as a coroutine because of, well, each time you're putting this async await word, you slow down the execution of the program by a little bit, because it needs to put the coroutine into event loop, start the execution, check that the coroutine was executed, and put another coroutine into it. So you might just want to use synchronous code as much as possible, because it's barely, it will always be faster than your synchronous code. Asynchronous code will be faster only in one case, when you have some read-write operations to another sources, like files, like databases, like, well, in this particular case, it's websites, yeah, and APIs. So this function, I won't go through it. You already seen it. It's pretty much the same. Here, we have something interesting, like get film history. We have IOHTTP instead of requests, because of it supports the Sync.io API, I would say. Yeah, it supports async and await. It supports asynchronous functionality itself. We're using it to get the data from the actors page and then parse it. And yeah, you might find also library here that helps you to go and to upload, not upload, to open the file and yeah, okay, to write the results into the file. This one is synchronous. You might find the synchronous analog. I haven't updated this code. You can do it by yourself after the presentation. So let's check. So quite the same idea, same code. You see that it's not that great of in performance improvement. I can prove you that if I'll run the same code again and again here, we might get even better results than a synchronous code. So just try, yeah. Well, maybe this time. Kind of. But no, the first one was greater. But I can prove you that this code can be as fast as as async code. Let's modify it a little bit. I will use sessions, request sessions, and I want open it and close it each time I try to request the page, the actors page. Oh, okay, here session, all good. This is great. I didn't want to debug, not a problem. I think I don't have any breakpoints. Let's rerun it. Well, I think I have internet lags because of translation. I did it previously and it actually worked quite great. Well, mostly the same. Let's try again. This time I will delete everything from here. It might actually slow down.
Andrii, we also have a question from Anton.
Yes.
Is it possible to get this code to try it on a personal computer?
Yeah. All code will be in GitHub repository. We will send you links and the presentation also will be there. So you might see here that it's actually quite fast. So I think, yeah, it's a little bit faster than our asynchronous code. I can try to run async code a couple times more just to have this medium value. Well, almost the same. So it's already good. Almost as async code. Why do we need to actually use this asynchronous then? Well, we need to use it properly, actually. If we will update the same code with the same idea, yeah, we'll put here session. Okay, and I need session here. Good, good, perfect. You might see the improvement will be good. I think a couple seconds will win. No, 18 seconds. God damn it. Cloud betrays me. Let's try it again. Oh, yeah. I know what should I do. I should also delete here all these files. And rerun. Well, even more than our synchronous code. What's actually wrong with it? Why we have this slow performance? The idea here, we are not running all these functions in the same way. A wait word actually awaits when the function will be executed and will return the result. And that is why we do it even slower than synchronous. Version. Yeah, as I said, synchronous version will be always faster if you're not doing it right with a synchronous version. Yeah, and if you're not using IO operations. How we can improve it? Well, I told you about the tasks and futures, and it's good tool to use. What I need here is I need to create task, and then I need to gather all the results. I need to add here. So gather function actually works with carding. We can do something like this. Yeah, we can do something like this, and then we'll understand. To unpack the values from the list, we need to use this asterisk, no, before the list. It basically unpacks all the cardings from the result list and puts in here. And now you will see the magic. Yeah, let's run it. Cool, right? Like it's already popped up mostly immediately.
Andrii, we also received a few questions here. First one, it's, have you had a case with intermittent thread lock? I have an async event loop which makes a post request. However, from time to time, the main thread is getting locked for about 17 seconds.
Well, I need to see the codes. I think I can help, but after the presentation itself.
Okay, and the second one, what if you delete a wait in actors loop?
What if I delete what?
Await, yes.
In actors loop. Okay, here's this actors loop. If I'm deleting the actors, if I'm deleting here await, well, we can delete anything. Yeah, we are getting the, let's try maybe delete it here. You see, it's already marked like, with yellow. It's warns us that we cannot use the cartoon without a wait. If we're doing like this, I think we will have only the cartoon object. As I said, you will have cartoon object, which won't be executed. It won't even start to be executed. It's just an object to perform some action on it. You see here, yeah, cartoon. I have 10 cartoons. What is going on? No problem. I think maybe there is one, but yeah, it's just a cartoon. It's not doing anything. Well, I even can prove that it's not doing anything. Let's delete it. Yeah, cool. So you don't have here any results. It won't be executed in any way. To execute it, you need either a wait word or you need to wrap it in the task and then gather it. Let's do it once again. Same idea for a gather. When you're doing this, I think your gather is results. The gather function returns an available object, basically cartoon or future, and you need to get the results. If you need to get the result of it, you need to use await here. Let's try once more. I think it will speed up a little bit more. A little bit, but not great. I think the most slowed here, the most thing that slows down here us, it's this open and right into the file, which I know that there is a library called IO open, IO file, something like that, where you can use Asynchronous API to write data into the files. Just standard Python doesn't support all of the sections. So, but yeah, most of the time we're getting results even faster. I think on one of my test runs, I gained performance like 2 times performance. My synchronous code was executed for 12 seconds, and this one was executed for 6 seconds. Yeah, let's try again, and then we'll have time for your questions. Well, mostly faster all the time. So be aware of this trick. Try to run your functions concurrently. Try to run it in the same time. I would say use create tasks a lot. And if you write in the program which has your operations in it, and you definitely know that there will be a lot of them, yeah, Asynchronous your way. If you're running some programs that will have, won't have mostly IO operations, and it will be mostly CPU bounded, then don't use Asynchronous. You will just bump up your time, and you won't get any speed. Thanks for attention. Questions, comments, ideas?
We receive new questions from Junia. Hi, Andrii. Tell please more about await on low level. How does it work?
Well, basically, it's a word that starts our execution. Like awaits, send the card into the event loop, and then awaits for results. Yeah, so it says by itself, it always will await the result of the execution. Until then, it won't go further, and it might not even pass the execution to another card in you. It will just sit here or here, yeah. And if it got the result, it goes further. If not, well, sorry. That's why actually create tasks. It's crucial because of you're running this get film function in a kind of simultaneous way, yeah, like parallel way, but not exactly. It goes until the session get, and then start something doing something, and when it sees that we have IO operation, it turns the execution to it passes the execution to another get film function, and so on and so forth. Is there any additional questions?
Yep. Roman asked us, when can asynchronous programming interferes with a process? Maybe you had cases when asynchronous programming was superfluous.
I'm not sure that I got the question. Well, if I understand correctly, interferes with processes when we in parallel using asynchronous programming and processes. If there's an idea, well, you can do it, and it's two completely different things, and we use processes to speed up our CPU bounded operations, and you might want to use processes if you have CPU heavy and IO heavy operations at the same time. Yeah. But usually you just need only one thing. You need asynchronous to work with apps, and you need processing, yeah, to calculate something CPU heavy. Where actually I can find those questions? Can you send me a link? I want to also read it.
Roman texted unnecessary, I mean.
Accessory? Sorry, still doesn't ring a bell. Well, I might answer you after the presentation itself, just in text, if you don't mind.
Yeah, it's all for now. I guess we can move on.
Cool. So yeah, all of this code will be presented in the GitLab. You will also have another code. You can try and touch it. The README tells everything about it. So it's a code about light statuses. I have there, like here it's the function itself. It reads the light statuses from the Redis queue and then uploads everything to the graphite. And well, yeah, you might populate your Redis queue with the send lights. I think there are also send lights in each folder. You can populate it in Redis with the light statuses, and then some additional magic, and you add in all of the statuses to the graphite to check the graphs. Yeah. So if someone interested in this one, please contact me. I can help you run it or describe what it's doing. There are a couple ways you can actually speed up this program by itself. I created the Asynchronous execution, yeah, the Asynchronous version of the program, but also there was the Asynchronous program using generators. Yeah.
Roman texted the questions in Ukrainian language. Коли воно не потрібно, тобто коли є сенс це використовувати, а коли це просто зайве.
Well, asynchronous programming or processing. Asynchronous programming you need to use only when it's IO operations, like when you're writing to the file, when you're reading from the file, when you're trying to read something from the APIs, basically. Yeah, like websites, different server APIs, databases. In other cases, when you have some mathematics in your program, when you're doing some heavy calculations, you don't want to use asynchronous programming because it will slow down your program, and it could slow down it by a lot. If you're using heavy calculations and you can parallel it, I would recommend using multiprocessing, because it's well, basically it's creating the copies of the Python executor, and it puts it into each additional CPU core and start running it. So they completely separated, just have the context copied. And these CPU heavy operations will be executed there much faster. I hope I answered the question.
It is all for now.
Cool. Then thank you guys for the attention. Please write me with comments, ideas, or if I can help you in any way. Back to you. Oksana?
Yeah, sure. Guys, do you have maybe any questions, any ideas, things to share with us? Yeah, we already received some comments that our participants like your presentation, and also Andrii, you are the best teacher and developer, so congrats.
Thanks. Who's brought that? It's a lie.
Yeah. So, guys, do you have maybe something more? Yeah, awesome. Thanks. Thank you, guys. We thank you all for your activity and your questions and everything. We already sent some information that you received here on this call. You will receive the GitHub, you will receive the presentation, and you also can connect me on LinkedIn and ask everything that you're interested in about some company, about the vacancies that we have. Yeah, I will be happy to share with you more information about us, and also if you have any questions regarding this presentation and so on. So thank you, guys. Thank you, guys. Bye-bye. Have a great weekend.
See ya. Cheers.